Okay, so we are going to do some example problems involving solutions and going over the properties of solutions and calculations of concentrations of solutions. And so this first question is from chapter 8, number 9, and it's asking us to write a balanced equation for the dissociation of each of the following strong electrolytes in water. So these are strong electrolytes, so that means they're going to completely dissociate and separate into their ions. And so we'll do an easy one first. We'll do KCl. So KCl is a salt. It's going to be an ionic compound. It starts off as a solid. It's going to be dissolved in water. And when it does dissolve in water, it's going to separate and dissociate into its ions, K plus and Cl minus. And the reason why we know it's going to be K plus is because when we look at our periodic table, all right, potassium is in group 1, and so that's going to be wanting to have a positive 1 charge. It's going to want to lose 1 electron. And Cl is group 7a or 17. It wants to gain 1 electron. And so it wants to become a negative charge. And so it does, and then when it's in water, it's going to be in the aqueous state. Aqueous coming from aqua and water. Then we can look at B. So B, we have calcium chloride, solid, and again, these are all strong electrolytes, all going to dissolve and completely dissociate in the water. So calcium is a group 2 metal, so it's going to want to become a positive 2 charge. And then we're going to have 2 chlorine minuses, all right? Because the 2 means that we have 2 chlorines in this compound, and so when it dissociates, it's going to form 2 chloride ions. Then the last one we'll look at is D. We'll look at a polyatomic. So we have iron, NO3, 3. Again, this is a strong electrolyte. And so one thing you want to note is that we have an NO3. It's a polyatomic. So the polyatomic anion here is going to want to stay together. The polyatomic wants to stay together. So it's going to stay as an NO3, a nitrate. And nitrates have a negative 1 charge. And so we didn't really go in depth into polyatomics. I would tell you what the charge would be, but you have to know that it's going to stay together. But NO3 has a -1 charge, and so if we have 3 of them, there's going to be a total of -3 charges from the NO3, or the nitrate groups. And so that means iron would have to be a positive 3. So iron would be a positive 3. And then we have that 3 outside the parentheses becomes the coefficient, and NO3 minus, and that is in the aqueous phase. All right, and so those are how you show the dissociation of these compounds, these strong electrolytes. All right, and the next one, it's asking us to find how many moles of each of the sodium and the chlorine we have in 1 liter of a salt solution. And so if we have 154 milliequivalents per liter of each of Na and Cl. So we're just going to concentrate on Na first, and then we'll do the Cl. So we want to get to moles. So what we want to do is go from milliequivalents. We want to get that into equivalents, and then we can get that into moles. Okay, And so first, to get into equivalents, we'll have to get into milli equivalents. So we have 154 milli equivalents per liter. And we know we have 1 liter. So that means we're going to have a total of 154 milli equivalents. If we have 154 milli equivalents, we can multiply that by 1 equivalent over 1,000 milli equivalents. And we get 0.14 equivalents. So we have 0.154 equivalents of Na plus. And so because Na plus only has a +1 charge, that means that in 0.14 equivalents of Na plus, we multiply that by a conversion factor of 1 mole of Na plus per 1 equivalent of Na plus. And that just comes from it only having a +1 charge. And so when we do that, we get 0.154 moles of Na plus. And because Cl is the same, all of the calculations are going to be the same. So for Cl minus, we have 154 milli equivalents per liter times 1 liter, and we get 154 milli equivalents. Then we're going to use the conversion factor of 1 equivalent per 1,000 milli equivalents, and we get 0.154 EQ. And so we have 0.154 equivalents times 1 mole of Cl minus per 1 equivalent of Cl minus. And we get 0.154 moles of Cl minus. And again, that 1 mole of Cl minus per 1 equivalent comes from the -1 charge. There's only 1 charge coming from the Cl. And so that's how you would solve a question like that. The next question is asking us to calculate the mass volume percents. And so remember that mass volume percent, or MV, percent is equal to mass of solute in grams divided by volume solution in milliliters times 100%. So maybe it'd be beneficial for you to write out the equation so you know what you'll be needing to use and what values you need for your calculations. So in A, we have 75 grams of Na2SO4, which is the solute. We have 250 milliliters of solution. So we're going to take our 75 divided by 250 times 100. And we get a value of 30%. And that's how you do that. And we can do another one. B. We have 39 grams of sucrose. And that, we want to write MOV. 39 grams of sucrose. And that's our solute. And then we have 355 milliliters of solution. the carbonated drink. And so we're going to take our 39 divided by 355 and times it by 100. And we get 39 divided by 355 times and we get 11% mass by volume. All right. So that's how you'd solve mass volume percent. So just make sure that you have the mass in grams and the volumes in milliliters. So in 37, it's asking us to calculate molarities. And so molarity, M, is equal to moles of solute divided by volume of solution. Now, I'm not going to expect you to memorize these formulas. They will be given to you, so you don't have to memorize them. But it's probably best to at least write them out as one of your first steps so you know where you need to go and what you need to have in order to solve for the problems. A is the easier one because it already tells us how many moles and liters we have. So we have 2.00 moles of glucose, which is our solute. And we have 4.00 liters of solution. So all we need to do is take 2 moles divided by, and that's of glucose, divided by 4.00 liters, and we get 0.5 molar solution of glucose. B and C are just one extra step. We'll just go to C since that's the most involved, and so that would be a harder one to solve. So it says we have 5.85 grams of NaCl, and that's the solute. We know that in our equation we need to have moles of solute. So in order to go from grams to moles, we need to use the molar mass. So grams to moles, use the molar mass, or molecular weight, whatever you like to call it. It's going to be the same number value. So sodium is 23. So we'll just do mm of NaCl equals 23 plus 35.5, and we get 58.5 grams per mole. And so if we have 5.85 grams times 1 mole over 58.5 grams, our grams will cancel out, and we are left with 0.1 moles of NaCl. It says we have 400 milliliters of solution, but we need the volume to be in liters. So we need to convert. You can do the King Henry died drinking chocolate milk method. In that case, we do 400, our decimals here. So we'd have to move over 1, 2, 3, and we'd have 0.400 liters. Or you could do the conversion factor, 400 milliliters times 1 liter over 1,000 milliliters would give you 0.4 liters. Either way would work. So we have to take our molarity is equal to moles divided by liters. We get 0.1 divided by 0.4, and we get 0.25 molar solution of NaCl. So So that's how we solve for molarity. The next part we'll be looking at how to use these concentrations to solve for maybe the part of the solute or part of the solution. So we're going to use now the concentrations. And so here it's asking us to use these mass volume percents to be able to calculate how much solute we're going to need to prepare these solutions. So in A, it says we have a 5.0% M over V. So that means we have 5 grams of KCl per 100 milliliters of solution. Okay, so what we do here is when we have these mass by mass, or mass by volume, or volume by volume, to use those percents, we're just going to use that number, that percent number, per 100 of whatever the denominator is. So in this case, we have 5 mass by volume. So it's 5 grams per 100 milliliters. So we're just going to take it out of 100. And that's the easiest way to do it. So whenever we have a mass by mass, volume by volume, mass by volume, use those percents out of 100 of whatever the denominator is. So we have 5 grams per 100 milliliters. And so it's asking us, and then it says we have 50 milliliters of solution. So in order to get the mass, the grams, we're going to take times 50 milliliters, which was given to us. And so then we get a value of 2.5 grams of KCl. So in order to prepare the solution, we measure out 2.5 grams of KCl and dilute it to 50 milliliters. All right, in B, it says that we have a 4.0% M by V of NH4Cl. So that means we have 4 grams of NH4Cl divided by 100 milliliters of solution. And then we have 1,250 milliliters. And so, in doing that, we get 50 grams of NH4Cl. And so that's how we would solve for that. Similarly, in 8.43, we're going to be trying to figure out the mass of the, in this case, mannitol that would be needed for a patient. And so in this case, we have a 20% M over V of mannitol. And that's how much, if he receives 100 milliliters, how much is he going to receive in 1 hour? How many grams would he receive in an hour? So it's 20 grams of mannitol divided by 100 milliliters of solution. And it says we have 100 milliliters of solution in that hour. And so we would get 20 grams of mannitol. And so, again, we're just making sure we take these, use the denominator as 100, and then we use whatever percent value as the numerator. All right, in 8.45, we're now trying to use the mass volume percent and try to solve for the volume. And so in this case, it says we have a 5% mass by volume of glucose. And so that would mean that we could either do 5 grams per 100 milliliters of glucose, or we could do in 100 milliliters, we have 5 grams of glucose. Either way, it would be the same. And so, since we're looking for volume, we want to figure out how many liters, that's the volume. Then we want to have the volume in the numerator. So we actually want to use this conversion factor here. We want our grams to cancel out, and we want to be left over with the volume. So if we know we have 100 grams of glucose, and then in 100 milliliters, there would be 5 grams of glucose. If we solve this out, we would get 2,000 milliliters of the solution. And then it asks for liters. So 2,000 milliliters, you could do 2 different ways. We can use the King Henry diet drinking chocolate milk. In that case, we move over 3, 2.0 liters. Or we could do the conversion factor 2,000 milliliters. And 1 liter, there's 1,000 milliliters. And so that would, again, give you 2.0 liters of solution. So that's how many liters of solution would be required to give this patient 100 grams of glucose in 12 hours. All right, in 8.49, we're using the molarity and the volumes to come up with the number of moles. And so here, what we can do is we're looking for moles. And so molarity, spelled it wrong, M is equal to moles of solute divided by liters of solution. So if we have in A, we have 3.00 molar equals X moles divided by 1 liter. And so in this case, we cross multiply and we get 3 moles of NaCl is equal to our X. And so that's how many moles of NaCl we would need. If you want to set up a triangle method, I know we've discussed triangle before. If you want to set up a triangle for M over V, we have moles on the top, molarity on the bottom, volume on the bottom. Just make sure your moles are in volume is in liters. That's the big thing. All right, and so that would be a triangle if you would like to use that. It won't be given to you, but if you want to use it, you can use it. In B, we have 1.00 molar of KBr, and that's equal to X over 0.4 liters. And so in this case, we would get 0.4 moles of KBr. Okay, we just cross multiply. 1 times 0.4 is 0.4. If you're looking for the moles, again, M times V will get you the moles. And then lastly, we have C. So this one is different because we have milliliters, and it's not uncommon to have volumes in milliliters. So we'll need to first convert. So 125 milliliters is equal to 0.125 liters. And you can use that, get that by conversion factor or by just moving your decimal over. And so then we get 2.00 molar equal to X over 1.125 liters. And so in this case we get 0.25 moles of the magnesium chloride. Okay? So that's how we would use molarity to solve for moles. Eight 8.51 is similar, but rather than just solving for moles, we have to find out the mass. And so it's just one additional step. And that one additional step is just using the molar mass. And so we'll just do A and C. So in A, it says we have 2 liters of 0.15 molar NaOH. And so what we'll need to do is first set up our molarity is equal to moles over liters. So we have a molarity of 1.50 molar equal to X divided by 2.00 liters. And so we get X equal to 3.00 moles of NaOH. Then the last step is to go from moles to grams. You need to use the molar mass. So 3.00 moles times moles in grams. And so grams over moles we need to use. And so we need to use our periodic table. NaOH, sodium, is 23. Oxygen is 16. Hydrogen is 1. So 23 for sodium plus 16 for oxygen plus 1 for hydrogen, you get 40. So 40 grams per mole. And so 40 times 3 is equal to 120 grams of NaOH. And that's how you solve that. And then we'll skip down to C. C is, so the trick here is because here we have a volume in milliliters. So we need to convert our milliliters to liters. So 25.0 milliliters is equal to 0.0250 liters. It says we have 6 molar, so 6.00 molar is equal to X over 0.0250 liters. So 6 times 0.025, we get 0.15 moles of HCl. Then solving for molar mass, 1 for hydrogen, 35.5 for chlorine, we get 36.5 grams per mole. So we want grams to be in the numerator, moles to be in the denominator, so our moles can cancel out. And so we get 36.5 grams per mole. Moles cancel out. And we get 5.48 grams of HCl. And will be the last one we'll do is 8.53. And this one's asking us to calculate volumes. And so A is asking us to calculate how many liters of 2 molar KBr to obtain 3 moles of KBr. So in A, we have molarity is equal to moles over liters. We have molarity of 2.00 molar. We have moles of 3.00 moles. And we're looking for the liters. And we cross multiply. We get 2.00 molarity times liters equals to 3.00 moles. Divide both sides by 2.00, and we get liters is equal to 1.5. If you want to do a triangle method, moles, molarity, volume. So since we are looking for volume, we cover up the volume and we would get moles divided by molarity, which is exactly what we did. Moles divided by molarity. And we got that value. And the next one we'll look at is B. B is asking for how many milliliters we would need of the solution to have 4.78 grams of salt. So, we need, in order to use the molarity equation, we need to have grams changed into moles. We need to convert grams to moles in order to use this equation. So we need to solve for the molar mass of NaCl. And Na is 23, Cl 35.5, and we get 58.5 grams per mole. So 4.78 times 1 mole divided by 58.5 grams. We want our grams to cancel out. And so we get 0.082 moles of NaCl. So we have 0.082 moles of NaCl. So we know the molarity is 1.50 molar. We know that we have 0.082 moles, and we're trying to solve for the liters. And so we get 1.5 liters is equal to 1.5 times L is equal to 0.082. Divide both sides by 1.5. And then we get the liters is equal to 0.054 liters. Then the last thing, it asks for milliliters. So we need to convert. And so we move our decimal over 1, 2, 3. So 54 milliliters is our answer. And so that covers most of the calculations from this chapter. And so if you have any questions, just email me, and I'll try to help guide you along to the right direction.